Hello, welcome to our first video for our Algebra Part 2 class. Since the beginning of the year, we have been reviewing material from last year. This is our first unit that is brand new to us, Polynomials and Factoring. So the first chapter of our Polynomial and Factoring unit is adding and subtracting monomials. Well, we need to know what a monomial is. A monomial is a real number, a variable, or the product of a real number and one or more variables with whole number exponents. Basically, what that whole paragraph is saying that monomials are one term. Some examples of monomials can include just a constant. For example, the number 8. We have variables as monomials, so let's say x. We can have monomials that contain exponents, so negative 4x squared. And we can have more than one variable with a coefficient. So let's say 2.5 x, y. Let's make it complicated and add an exponent cubed. These are all single terms. Can you come up with 2 to 3 or more examples on your own? So 2 or 3 more Soslabi examples on your own. So when I go through your packet, I should see my examples, 8x, negative 4x squared, 2.5x, y cubed, and I should see 2 to 3 more examples. You can either do that right now and pause the video, or you can go back to it. So we know what a monomial is. Now let's talk about what the degree of a monomial is. The degree of a monomial is the sum of the exponents of its variables. So for example, we have negative 4x squared. That degree would be 2. 2.5xy cubed, the degree would be 4 because we know that the exponent that is attached to x is a 1. 1 plus 3, our degree would be 4. However, the degree of a non-zero number or constant, hopefully you know what constants are, 1, 2, 3, so on. Added 2 there, I don't know why. Is just 0. So the degree of 8 would be 0, the degree of 1 would be 0. But what about 0? The number 0. The number 0 has no degree. So let's practice. We have 5x. That degree will be 1. 6x cubed, y squared. That degree will be 5. We're taking the sum of the exponent values. And the degree of 4, well, we talked about the degree of a non-zero number or a constant is just 0. So that would be 0. There are 3 more to complete. Please do those on your own. Like I said, you can pause the video and do them now, or you can do them at the completion of the video. So on your own, complete these 3. Next, we can add or subtract monomials by adding or subtracting like terms. So on your paper you can add or subtract monomials. You have to write by adding or subtracting like terms in the space provided. And this is not the first time that you have combined like terms. You have done this many times. You guys should be semi-pros at this. The only real pro here is me. Just kidding, not really. Anyway, so what is the sum or difference? Well, let's take a look here. Do we have like terms? We absolutely do have like terms. So we will add the coefficients and keep the variables. 3x squared plus 5x squared. We have 8x squared. Now if we're subtracting, we'll check to make sure we have like terms. Yes, we do. So now we will subtract our coefficients, keep the variables. 4 minus, there's a 1 here. We should know that, but just in case you're wondering where it comes from, I'll write it in there for you. So 4 minus 1, that is 3, and we're going to keep our variables the same. Combine like terms. Okay, next, adding. We have x squared and x squared y to the 4th. So we're going to add, just kidding, we're not going to do anything. Why? Because they are not like terms. That was close. So I have 5, nope, Miss B, you cannot add these together. They are not like terms. So I will just have 3x squared plus 2x squared y to the 4th. Done. What is not done are these two. Please complete these either right now, pause the video, or later. Oh, my goodness. Are we enjoying the video so far? I am. Oh, there's the bell. Time to go. Just kidding. I don't think I can do that. All right. Where are we? Yes. So, we found the sum or difference by combining like terms. Those are monomials. We are talking about polynomials now. A polynomial is a monomial or sum of monomials. We know that monomials are one term. They are single terms. Polynomials can be one or more terms. So, we have an example of a polynomial. 3x to the 4th plus 5x squared minus 7x plus 1, which is the sum of single monomials, just monomials, 3x to the 4th, 5x squared, negative 7x, and 1. So, just as a refresher, let's talk about the degree of each of these monomials, and you'll see why we're doing that in just a second. So, the degree of the monomial 3x to the 4th, 4. The degree of 5x squared is 2. The degree of 7x is 1. And remember, the degree of a constant is 0. So, what do you notice about the order of the degrees of each polynomial, or in each monomial and the polynomial above? Monomial, 1. Polynomial, multiple. Kind of a fun word to say, both of them actually. So, you should notice that...
May I have your attention, please?
Oh.
There's an Adventure Club meeting in room 106. There is an Adventure Club meeting going on right now in room 106. Thank you.
In 106, apparently. So the degrees decrease from left to right. So they decrease. They are going in descending or decreasing order. So they decrease from left to right. Or you can say the degrees are in decreasing order. if you look at the bottom, it says that this is the standard form of polynomials. So whenever you see a polynomial that is in standard form, the degrees will be in descending order. So x to the fourth, if that is your highest degree monomial within that polynomial, that will be farthest to the left. If you have any constants, they will always be to the right. Next, the degree of a polynomial in one variable is the same as the degree of the monomial with the greatest exponent. So, monomials, we know that the degree is the actual value of the exponent. In a polynomial, the degree of the entire polynomial depends on the degree of the highest exponent value. So the degree of the polynomial 3x to the fourth plus 5x squared minus 7x plus 1 is just, you guessed it, 4. You can name polynomials based on its degree or the number of monomials that it contains. So we have 6. 6 has a degree of 0. It is a constant, and it is only one term. We know that it is a monomial. The degree of this polynomial is 1 because we look at the highest exponent value. There's none here, and we assume that this is 1. We don't really assume, we just know it because we are awesome, smart mathematicians. So the degree is 1. It is linear, as you notice. It looks like it's in slope-intercept form, y equals mx plus b. We'll save that for a rainy day. Number of terms, there are 2 terms. So its specific name is a binomial. Going back to our polynomials, we have 4x squared plus 7x plus 3. We're going to look at the exponential value that is the greatest, which is 2. The polynomial has a degree of 2. It is a quadratic. We'll learn about that later on in the year. And it has 3 terms, so it is a trinomial. I'm just emphasizing the mono, meaning 1, the binomial, meaning 2, trinomial, meaning 3 terms. Next, we have 2x cubed, degree of 3. It is a cubic due to the degree. It has 1 term, so it is a monomial. Do the last one on your own, please. So, to add polynomials, add or combine like terms. So, let's go over a real-world example. A researcher studied the number of overnight stays in U.S. National Park Service campgrounds and in the back country of the National Park System over a 5-year period. Wow, long time. The researcher modeled the results in thousands with the following polynomials. So instead of writing out his research solely using numbers, there was so much of it that he decided to add variables into it. So the campground is represented by negative 7.1 x squared minus 180x plus 5,800. Backcountry represented by 21x squared minus 140x plus 1,900. So this is kind of a fluffy statement right here. It's fluffy. It makes the math more appealing, more interesting. What we as Algebra Part 2 students are concerned about are the numbers. So in each polynomial, x equals 0 corresponds to the first year in a 5-year period. fine and dandy. What I'm worried about is what's highlighted. It's not the greatest on your paper. It's super dark. I'm super sorry about that. Anyway, what polynomial models the total number of overnight stays in both campgrounds and backcountry? So when we look for a total number of something, we should know that we need to add. So we are going to add the coefficients and keep the variables. To easily add these two polynomials together, we are going to line up our like terms. This has already been done for us. Super nice. So let's start. We have a negative 7.1x squared, and we are adding 21x squared. We add that together. We get 13x squared. We have a minus 180x and a minus 140x. We will add those two numbers together, and we get a negative 320x. Now we have rather large constants to add together. 5,800 plus 1,900, I have 7,700. So the polynomial that models the number of stays in thousands in campgrounds and backcountry over the 5-year period is represented by another polynomial, 13x squared minus 320x plus 7,700. Not too bad, right? Adding polynomials, just combining like terms. Now, let's get into subtraction. Subtraction means to add the opposite. So to subtract polynomials, you will change each of the terms to its opposite. Then you will add the coefficients. Coefficients. It's a rather hard word. Anyway, so let's dive right into an example. What is a simpler form of x cubed minus 3x squared plus 5x minus 7x cubed plus 5x squared minus 12? We need to line up our like terms. This makes our life so much easier, and you'll see why in a different example. So it's already done for us. That is amazing. So we're going to add up like terms, and we're going to change each of the terms to its opposite. So we will have x. Where are we going with this here? Ah, yes. So it's lined up. So next we are going to change the sign for each of these monomials. That's why I have that line there. It makes perfect sense now. So we will have x to the third minus 3x squared plus 5x. Now I'm going to negate each of these terms, and I'm going to be very careful with the placement of my terms. So I have 7x to the third. We negate it, so I will have negative 7x to the third. That says 3. I made it worse. I will have a minus 5x squared. I don't have an x term, so I'm not going to write anything right here. That way we know not to add anything or subtract anything from it. And I have my constant over here. It's a negative 12. A negative times a negative 12 is a positive 12. So now, instead of thinking about keep, change, change, thinking about subtracting negatives, I'm just going to combine my terms. So I have a negative x cubed and a positive x cubed. That simplifies to negative 6x cubed. I have a negative x squared plus, I won't forget that plus sign right there, a negative 5x squared. So when I combine those, I have negative 8x squared. I have nothing to combine 5x with, so I'm just going to keep 5x. And I have nothing to combine 12 with, so I will just keep 12. Not too bad. An extra step compared to adding polynomials. So now when we're subtracting, we have to negate each term, and then we can add them together. So you have an example to do on your own. If you need help, please bring questions into class. So that is it for our first video. Like I said, if you have any questions, please bring them into class and bring your completed notes to class as well. Thank you for watching, good evening, and good night.